All right, for this section of notes, guys, we're going to talk about the 1-2 points, lines, and planes. We got a few definitions to go through, so let's get through those first. First one being a point. A point is a location and it has no size. So over here at the right, you see the diagram of a point. All it has is a dot with a letter to represent what that would be called. So how would we name that? We would either just say A, or you'd write out the word point A. Either one of those would work, but when you read it as point A, it would be the most likely way of seeing it. All right. We have a line next. A line is a straight path that extends in two opposite directions and has no thickness. Remember this, it has infinitely many points. That will come up here in a little bit as well. So a line represented over here to the right, you'll notice that it has arrows on both ends. If it does not have arrows, it would not be considered a line, which we'll get to here in a little bit. So when we go to name it, there's a few ways that we could name this. The first way we can name it is line with the word AB. Now you could do it that way, or you could do AB with the line symbol over top, which we would still read as line AB. There's another way you could do it, and it's not written up here, but if there's a little cursive letter on either end of it like that, you could also call it line L for this case, because that's what letters there, or line M, whatever they put there. All right? And it's usually represented by a cursive letter. All right. Next up, we have a plane. A plane is a flat surface that extends without ending, and it has no thickness. It contains infinitely many lines. So a plane, to think about it, is like a piece of paper that goes on forever and ever and ever. It never ends. So it's a flat surface like that. So when we go to name a plane, there's two ways you can name it. The first way being using three letters that do not make a straight line. So for this one, we would call it plane A, B, C. Now we cannot use P in this case because does P have a dot next to it? No, it does not. Therefore, it's not a point. It's actually another way that we can name it. If you see a letter anywhere in there that doesn't have a point, means it's not a point, which means you can call it plane P, as long as there's not a dot there with it, all right? All right, next up, we have coplanar. Coplanar is points and lines that lie on the same plane. So if you look over here at the figure on the right, A, B, and C both are inside of that plane. Therefore, they would be coplanar. You could also draw lines on it. An example, if I did something like this and this, both of those lines are on the same plane, so those would be coplanar as well. And then, of course, non-coplanar are points and lines that do not lie on the same plane. Now, these get a little bit tricky because when we're writing stuff down, it's a two-dimensional surface, which means it's hard to represent three-dimensional. So you'll notice C is over here off to the side. That's how they're going to represent that something is not on the plane. You can identify it as not being on there because that's the way that they wanted to write it. And they can't really do much better than that without it being a three-dimensional object, all right? Next up, we have collinear points. Collinear points are points that lie on the same line. So you'll see A, B, and C there. All three lie on the same line. Therefore, they would be collinear. And next one, we have non-collinear, which of course would be points that do not lie on the same line. You'll see it over here again. You have A and B on the line, but C would be non-collinear because it's not on the line with A and B. All right? Next up, we have a segment. A segment, by definition, is part of a line containing two endpoints. So you'll see over here to the right, it's like a line, but it does not have an endpoint. It does not have arrows on either side saying it's going on forever and ever. So it essentially makes sure that it stops, all right? When we're writing it, you can either say the word line segment AB, or you can represent it by writing AB with a line segment over top without using arrows. Now, you could put the dots on there if you want. Most times you won't see it with it on there, so we usually just do it this way. But that's how you would name a line segment, all right? Next up, we have a ray. A ray is part of a line made up of an endpoint and infinitely many points going in one direction. So one way to think of it is it starts at a point and then it goes on forever and ever and ever in one direction. We're going to name both of these here because there's a tricky way to name one of those two. The first one should be very easy. You're going to say ray AB, and when you do that, the symbol will point to the right. Now, the one that's the most difficult is the next one, and this is the one that a lot of people have an issue with because you need to understand that the arrow still goes to the right. That will never change. But when we're naming it, we cannot name it CD because C is not the endpoint. We actually have to label this one DC because we always start at the endpoint. So it doesn't matter what direction the ray goes, but you do have to name it by starting with the endpoint every single time, all right? Next up, we have opposite rays. Opposite rays are when you have two rays that share the same endpoint and form a line. So you'll see essentially we have a line here over here to the right with 3 points. The two opposite rays will be the rays that go in opposite directions. So you have one ray that goes to the left, but then you also have one ray that goes to the right. And we have to use both of those to be considered opposite rays, but they share that same middle point. So the first ray we will call BA because it starts at B and works its way to the left to A. Now remember, we still draw our arrow pointing to the right regardless when we're identifying it, okay? And then our second ray that would be considered the opposite ray with that would be ray BC. All right? Next up, we have a postulate. A postulate is what we would call an accepted statement of fact. You're going to hear this a lot throughout the year, especially when we get to these things called proofs. An accepted statement of fact is just simply saying, if I tell you it's true, it's been proven true, you don't have to worry about going through that process. When we get to proofs, you'll understand why we don't want you to have to keep doing it over and over. So once we prove something, we kind of put it in this postulate pile and say, well, we can use it forever now without having to prove it. So that's going to be a big thing that's going to help you when we get later on into this year, all right? Next up, we have an axiom. Now, an axiom is very rarely used, but it is still an accepted statement of fact, or a postulate. So it's just another word for it. We don't use it as much anymore, but it still could pop up, so be ready to see that. But it is still a postulate or accepted statement of fact, all right? And then an intersection is a set of points geometric figures have in common. So we're going to go into this a little bit more when we break it into some diagrams, but here's 3 examples of it. The first one you need to know is where we have 2 lines that intersect. So you have this line and this line that intersect, and you'll see they intersect at this point right here in the center. So we're about to learn that whenever you have 2 lines that intersect, they can intersect at exactly 1 point. Then you have this plane and line right here. When you see the plane and line, you'll notice that right here we have a dot. That's where they would actually intersect at. Now, it's hard to do this again without it being 3-dimensional, but the reason that this dotted line is right here is because they want you to understand that that's like something you can't see. So it would be underneath the figure. So that tells us it's going through. You can't see it at that point, and then you regain being able to see it over here, all right? So that's kind of how they're going to represent that in a 2-dimensional world with 3-dimensional type of objects, all right? And then the last one, we have 2 planes over here. They're going to intersect at this line. Now, a lot of people say, well, this doesn't keep going on forever and ever, so it's technically a line segment. However, remember, a plane does not end. Therefore, that line you can automatically assume does not end, even though it doesn't technically have the arrows on it, all right? All right. So let's go through this. What are 2 ways to name QT? Well, QT is this line right here. And again, you'll notice that it has that dotted line there. So it's represent that it goes through the plane. So to name QT, we can name it 2 ways. We can pick any 2 letters that we want that are on that line. We can't use QT because it's already been used. So I'm going to use NT. So we're going to say line NT and put our symbol over top. And then the other thing we could do is you notice that it has this little cursive M down here, even though it doesn't really look cursive the way that they write it. You can also call it line M, all right? So either one of those would work. You could have also called it NT, it's the same thing. Any of those would work, but you cannot call it line MQ because M technically isn't a point, right? All right, so what are 2 other ways to name plane P? Well, for naming plane P, you need to use either the letter that's used, which is P, which they already did, so we can't use that, or we have to use 3 points that do not make a straight line. So could I use QRS? No. And the reason why is those 3 actually form a straight line. So I can use RSV, so we'll call it plane RSV. Or We could also call it plane RQV. Now, the order that you put the letters does not matter. Most of the time, you're going to see them in alphabetical order, but it doesn't necessarily have to be that way. All right? What are the names of 3 collinear points? So we just need 3 points that lie on the same line. There's actually 2 answers you could use for this. Depends on if you're using line RQS or line TQN. Either one of those would work. In this case, I'm going to use T, Q, and N. So point T, point Q, and point N. All 3 of those would be collinear points because they lie on the same line. And then how can you tell P is naming a plane instead of a point? What is the key there that it's naming the plane instead of a point? The fact that it does not have a what? Dot, right. So no dot, however you want to represent that it's not a point because it does not have a dot next to it. All right? Next up, naming segments and rays. What are the names of the segments in the figure? So we're just going to do a couple here. We're not going to do every single one because it takes a while to do that. To name a segment, guys, you just need to get 2 points and make sure that they're ending there. So the first one I'm going to say DE. DE would give us 1 segment right here. All right? And it tells me that it ends there. Let's do another one. We could do EF. There is one last one that we could do. I'm going to go ahead and do it while we're here, and that's DF. All 3 of those would make segments. And you could, again, switch the order of the letters around. However, they will typically do it in alphabetical order, so I would suggest you try doing the same, all right? What are the names of the rays? There's a couple of different rays. Let's start with one. Let's go D to F, all right? So what that's telling me is that I'm starting at D, and then I'm going this direction forever and ever, all right? So that's one ray that we could use. I could also use EF. If I use EF, it says I'm starting here and going that direction. I could also use ED, which means I'm starting here and going in this direction. You could also use FE or FD as well. All right? Now, which rays above are opposite rays? Well, if you notice, I left it drawn up there for a reason. If you see EF and ED going in opposite directions, they share that middle point. That's the key with opposite rays. They have to share that middle point, which is what they're going to be, is what would be going in opposite directions, right? So the 2 that are up above would be EF and ED. Those would be your 2 opposite rays because they're going in opposite directions. Excuse me. All right. Next up, we have through any blank. There is exactly blank lines. So what that says, through any 2 points, there is exactly 1 line. So no matter where I put 2 points, you can only draw 1 line every single time. All right. The next one, if 2 distinct lines intersect, then they intersect at exactly 1 point, which means if I have 2 lines that cross, they cross exactly 1 time. They can never cross more than that. To do that, they would have to bend. In that case, if they start bending, then they're no longer considered a line, right? All right? If 2 distinct planes intersect, then they intersect in exactly 1 line. Now, if they intersect at 1 line, that means there's infinitely many points, but we consider that 1 line. So in this case, you see 2 planes. They're actually intersecting at this line right here, which would be called line ST. All right? So let's do this example here at the bottom. It says, find the intersection of 2 planes. What is the intersection of plane ADC and plane BFG? So what you need to do with this, guys, is you need to draw your planes out. So if I start at A, then I go to D, then I go to C. If I'm going to get back to A, I have to pass through 1 more point to make that complete plane, which would be B, right? So essentially it's like the top of this box. All right? The next one we're going to do is plane BFG. So I start at B, go down to F, and then over to G. Once I've done that, the only way to get back to B is to pass through point C. Now, there's one line that I drew over twice right there. There's a blue and an orange right here, correct? So if you look at that, that would be where the two planes intersect, which would be line BC. Now, sometimes you can tell this without actually having to do the work. The problem is C is not in both. You'll see some where you'll be able to do that. But what I would suggest doing is drawing on there like that every single time to be able to figure out where they intersect, all right? Through any three non-collinear points, there is exactly one plane. Which means no matter where you draw 3 points that do not form a straight line, you can only make one plane. So like R, S, and Q, there's 3 points there, they can only make one plane through it. All right? So using the figure, what plane contains N, P, Q? Shade the plane. So when you're doing this, guys, you go through, you start at N, you go to P, then you go to Q. Once you've done that, the only way to get back to N is you have to pass through point R, all right? So when we call it, we're going to call this plane, and then you could use any of those 3 letters you want. And go in order of whichever way you want to go. You could have actually just called it NPQ and not done any of the work, but you still have to shade it in, all right? For the next one, I want you guys to go ahead and pause it here, but I want you to try it and then play it, and then I'll show you exactly how it is. For this one, I want to give you a big hint here. You need to think inside of the box with a lot of these things, all right? That's a big hint for you, all right? So go ahead and pause it here, give that one a shot, and then I'll go over it once you're done. All right, so for this one, you should notice the 3 letters they give you. It gives you J, then you go to M, but then I've got to go to Q, which is all the way down here. So it's drawing a diagonal right there, right? So if I want to solve this, I now have to actually pass through P to get back up there. So if you think about it, you're shading kind of like a ramp inside of this box. So what it is it's something diagonally inside the box is what you need to think of on a 3-dimensional plane. So when we call it, we could still call it the same plane that we want, which is JMQ, but you also could have added the letter P in there to represent that. All right? So these are your notes for 1-2. Make sure that you bring these notes in with you next class.